So here we go, this is my oscilloscope, and we are connected to the motor. The ground is to B-, and the probe is connected to M-. So this should give us drain source voltage. If you can see here, this is the voltage we're currently reading. We're at 50 volts per division. And so currently about, this says 157 volts, but it's really about 150. This must be off a little bit. Anyway, let's see, I wanted to start. We're here at 10 microseconds per horizontal centimeter, and you should be able to see the waveform quite nicely. So when we're like this, and we're having at 50 volts in the vertical axis per square, it's definitely hard to see any voltage spike. If you're curious how many amps we're pulling, here's the amp meter, and I'll rev it up again. So maybe we are in the mid 100s, maybe 200 amps at the peak there. I'm going to zoom in on the horizontal axis, going down to, let's see, 100 nanoseconds. 100 nanoseconds per horizontal square, and we're able to see the voltage spike a little bit better. So if every horizontal dot is 1/5 of 50 volts, so that's 10 volts, we're at about 2 or 3 little dots for that little spike above the battery voltage line, and so that's another 20, 25 volts maybe. Now of course, you may also notice that the line comes down, the horizontal line comes down a little bit. And I think that's just due to voltage sag, but that's what I'm talking about as far as the tip of that peak to the horizontal line. So that's that.